7,300. Now, that's not just some random number on a page, folks. It's actually a massive, profound marker in geological time. Literally, exactly 7,300 years have passed since the Kikai supervolcano triggered the absolute most massive eruption of the entire Holocene epoch. To put that sheer scale into perspective for you, we are talking about an explosion that easily dwarfed the 1980 eruption of Mount St. Helens by hundreds of times over. An explosion so insanely violent that it permanently scarred the Earth, leaving behind a gargantuan crater deep beneath the waves. Now, for millennia, that colossal submerged caldera has been relatively quiet, but as we're about to see, quiet definitely doesn't always mean asleep.
Welcome to this visual explainer. Today, we're unpacking exactly what scientists have just discovered miles beneath the ocean's surface off the coast of Japan. We're looking at hard data from a truly groundbreaking piece of research published in April 2026 in the journal Communications, Earth and Environment, proving that an ancient supervolcano is currently refilling with magma. I'm going to walk you through exactly how researchers figured this out, what it looks like, and crucially, what this all means for the future of our planet.
Section 1. The Monster Awakens. Okay, let's dive into this.
To truly grasp the magnitude of this recent discovery, we really have to look at the scene of the crime first. When a supervolcano erupts, it empties its magma chamber so violently that the ground above it actually just collapses, forming this massive depression called a caldera. Kikai's eruption was so immense that its caldera is a huge geological feature, and it remained totally shrouded in mystery for thousands of years just because of where it's located. Looking right here at the visual structure on the slide, you can see this 3D bathymetric map of this submerged caldera. Its underwater location makes it incredibly tough for humans to physically access. I mean, you can't exactly hike down there with a rock hammer, right? But as the researchers pointed out, being submerged under billions of gallons of seawater actually makes this site uniquely perfect for specific types of high-tech geophysical surveys. You see, seawater transmits certain acoustic and seismic signals incredibly well, basically turning the ocean itself into a giant lens so scientists can peer straight into the Earth's crust.
Section 2. An underwater investigation. Let's get into the detective work.
So how exactly do you study a completely submerged supervolcano? Well, this recent expedition was essentially a high-tech undercover investigation led by Kobe University and JAMSTEC, the Japan Agency for Marine Earth Science and Technology. They basically treated the ocean floor like a giant patient in need of an ultrasound. To do this, the team used a super precise three-step methodology. Step 1, they deployed a vast network of incredibly sensitive underwater seismometers all across the ocean floor. Step 2, they generated targeted seismic waves, basically sending sound pulses deep down into the bedrock. And finally, Step 3 involved mapping the caldera's internal depths by recording exactly how those waves bounced back. Different materials, like solid rock versus liquid magma, reflect those waves totally differently. By catching those reflections, the team literally drew a map of the hidden depths below.
And let me tell you, the results of that mapping process were absolute dynamite. The researchers completely succeeded in locating a massive magma-rich basin right beneath the site. But here's the absolutely crucial part. The newly mapped reservoir is the exact same size and sits in the exact same location as the one from 7,300 years ago. They proved beyond a shadow of a doubt that we are looking at the exact same volcanic system that fueled that ancient cataclysm. It hasn't shifted, it hasn't shrunk, the architecture of this monster is fully intact. It's kind of like finding the engine of a wrecked classic car and realizing the thing is still running.
Section 3. The Shocking Discovery. Now, what's really interesting about this slide is,
Finding a magma chamber is one thing, right? But figuring out the actual state of the magma inside it changes the whole game. For years, there was this massive scientific debate. Side A represents the long-held assumption. Scientists honestly thought that any magma found down there was just cooling, residual leftover stuff. Basically the dying embers from that 7,300-year-old eruption. But Side B shows us the stark reality. The researchers did some really rigorous geochemical analysis on a lava dome that actually formed within the caldera over the last 3,900 years. And the chemical signature of that rock tells a crystal-clear story. This isn't old residual sludge, it is a completely new, active magma supply. The supervolcano isn't just sitting there, it's actively refilling itself.
And this brilliantly illustrates the hard scientific evidence mapped out by Ainagaya and the research team. Check out those deep red zones on the heat map. That isn't just slightly warm rock, that represents the melt fraction. We're talking about the percentage of actual liquid brand new magma actively pooling 5 and 10 kilometers beneath the seafloor. It's a vivid, structural blueprint of a supervolcano gathering its strength back, accumulating fresh, molten rock right inside the exact same chamber that once completely devastated the region.
Section 4. A global threat.
You know, it's super easy to write this off as just a localized issue for Japan, but the implications of a supervolcano refilling its primary magma chamber carry some massive global stakes. This specific discovery matters to everyone everywhere because it completely changes our understanding of the life cycle of these planetary giants. For starters, this active refilling directly mirrors the magma reinjection processes we've seen at other major calderas worldwide, most notably Yellowstone in the United States. By studying exactly how Kikai's new magma behaves, scientists can better identify the precise warning signals that might precede a global cataclysm. Plus, the cutting-edge underwater techniques used by Kobe University in JAMSTech are an absolutely crucial stepping stone. They dramatically improve our global methods for monitoring future titanic eruptions, no matter where they happen to occur.
Which brings us to the ultimate takeaway from all this research. The Kikai caldera has definitively proven that these ancient geological titans don't just die, they reload. We finally have the technology to map the magma pooling in the dark, silent depths beneath our oceans. But mapping the threat is only the very first step. As new magma silently fills the ancient chambers beneath our oceans, are we genuinely ready to read the warning signs of the next global super eruption before the monster fully awakens?